to recording. Okay, now we're recording. This is Bill Spohn with TrueTech Tools. This is another edition of TrueTech Training. Today we're going to be talking about the BPI 1200 standard, the proposed standard, and its impact on your test gear. And this is revised as of just this morning. There's some new information out. A new version of the standard is out for public review and comment, so there's a new opportunity to comment. If you're watching this on a recorded version, things may have changed and migrated since this was recorded. So please be sure to check with the latest standard to make sure you're reading the correct information. For your info, TrueTech Tools is a stocking distributor of over 50 lines of products. Our goal is to make measurement science work. We try to do that by communicating, by learning, by understanding, by working with people, working with customers, manufacturers, and we present that information in the context of free webinars, downloads, trainings, guides. We also like to participate in the CEU process. So in this case, there is one BPI CEU for this class. We'll talk about how to make sure you achieve that and some other details on that in a moment. Our bottom line is we want to see you do it right. We want to make sure you have the right equipment, the right gear, you know how to understand it, and you understand the measuring science behind it. And we think the best way to do that with TrueTech is to connect. One of the best ways is with our newsletter, or if you want to connect on other forms of social media, we'll give you all the links at the end on how you can hook up and stay up to date with TrueTech. With regard to BPI CEUs, there is one CEU for this class. Best thing you can do is stay on the screen. Don't drift away and click on another window. Don't go read your stock reports or check on the price of bananas at the local supermarket. Also, I'd like you to answer the polls. When you do that, that's very helpful because that shows interaction. The biggest question we get afterwards isn't usually a technical question after a webinar, but it's when do I get my CEUs? TrueTech is required under the new system to submit a report for the training to BPI within 72 hours, and we do that. Then it should automatically appear in your training portal. If there's been an error and you did not enter your BPI certificate number correctly, that could be the source of the error. That's been the errors we tend to come up with. Either people didn't enter their correct certificate number or they didn't enter one at all. If you do have any trouble, please contact TrueTech first with regard to your CEUs for classes that we offer. And you can contact Jamie at TrueTechTools.com and she'll help you out. So let's run poll question number 1. And this is an optional thing, but it's good just to kind of get our heads going and see what kind of field of work is everyone today here in. Just go ahead and click on the screen with your answer. Multiple choices are allowed. Okay, we'll wait for the voting to come up. And we're over 70%. So we'll close the poll, share the results. 50% are in do work in weatherization and community action, with another 33 in building and home performance. Pretty much makes sense for this group because it is a BPI related session. So the BPI 1200 is still in draft. In fact, the latest draft was put live about 10 days ago or so. It's open for public comment until December 15th. So there's a very easy way to find that. In fact, I'll take a break right now from the presentation and I'll jump to a live web screen if you give me a moment. And we'll show you exactly where that is at bpi.org. So I'll bring the screen live again here. So we're at the bpi.org website. If you click under BPI standards, you'll see standards that are current and then standards that are under public review. When you click under the public review, you'll see the standard that we're talking about here, BPI, BSR, ANSI, BSR, BPI 1200, Standard Practice for Basic Analysis of Buildings. It's available for review and comment until Monday, December 15th. There's a public comment process and a form. And you just go ahead and click on the link here, and it will actually take you to a PDF so you can download and review the standard. And there have been some significant changes. The last set of revisions was last November, and things have changed since then. So this review has been made available during the month of November here. So let's go back to our presentation and continue with things. Okay, so it's still in draft, but you have a chance to comment and the new draft is out there. It's an ANSI standard, which means the American National Standards Institute has a process by which BPI must follow to make a consensus standard. This statement here is incorrect. The public review is actually, I'm going to change it right now, live in real time. It's open until 12/15/14. And the other public review is happening right now. It's not been put into practice, but some people are still training to it. And I would say that this next revision here that you have in front of you is probably the one to train to, because I think it has gone through perhaps the last iteration. There is a download available, as I just showed you a moment ago, on the site. Want to make sure everyone is aware, if you have questions, you please type in the question box, and I'll do my best to answer the questions so we can keep the spirit of the conversation moving. So because it's an ANSI standard, and here we're showing sausage being made, there is actually a procedure that goes along with how the standard's made. I have a short link here to the procedure. You could find it on BPI's website. It's bit.ly/BPI procedure. Make sure you hit the uppercase BPI and the lowercase procedure. That will show you, go through the process by which they create the standard. John Jones is the National Technical Director for BPI. He oversees the standards and development activities, and he's also there to ensure compliance. He can be reached at jjones@bpi.org if you have any questions about it. John's a very good communicator, likes to hear questions, and really help to build the best consensus standard he can. And by consensus, that means that all parties, all players, all stakeholders in the industry are taking part in development and review and making sure it's looking out for the best interests of everyone. And as an ANSI standard, it does reference other standards. So you may see within the standard itself a reference to other standards. The idea there is not to reinvent the wheel, but to build upon it. It's tough work. I did have a screenshot of the committee list, but you can see if you download the standard, it's a very lengthy committee list. A lot of people were involved in feedback on the standard to create a good document. So let's shoot off poll number 2 here and find out how long people watching this today, participating today, have been doing work with BPI standards. Okay, we got well over 70% voted. Let's share the results. So we're in the more experienced crowd, 2 to 5 years, and then more than 5 years. So 80% of the people have more than 2 years doing this kind of work. So these are some changes, as you can recognize. You've been doing this for a while. There have been some changes here, and that's a good thing. Change in migration is a good thing. It helps to build a good, robust industry. So our focus is on Section 7. This table of contents probably has the wrong page numbers on it because it was based upon the previous standard. So ignore that, but mainly I'm just trying to show there's a lot of information in the standard. We're really going to focus on one small area, but an important area, the combustion appliance and fuel distribution inspection. If you're not familiar with ANSI type standards or consensus type standards, you do have to watch the wording and make sure you understand what the words mean. The word shall means a mandatory requirement. It's the equivalent of saying must. It's something you must do. May, when used in a standard, indicates permission. It means it's neither a requirement or recommendation, but it's okay to do. And should, or is recommended, is it's not mandatory, but it's just good practice. It's more or less advice. But if you see the word shall, that's something you must do in order to stay in compliance with the standard. We'll be talking about CGDs today. CGDs are combustible gas detectors. That's one of the primary products that's used in the safety inspection for BPI 1200. Now, I've got the new numbering from the standard shown here. Hope I got everything correct. But it's section 7.1.1, 7.1.1.1. That's another great thing about standards. Lots of layering of detail. Combustible gas detectors shall be intrinsically safe. Now, when that statement is made, that indicates that the equipment must be incapable of creating an explosion or ignition to an atmospheric hazard, a hazardous atmospheric vapor, in its most easily ignited concentration. So we're going to go into what that exactly means, and again, give you an idea of the science behind it. Now, this is achieved in the gas leak detector by limiting the amount of power that's available inside of it to get into the hazardous area below, to keep it a level below which it will ignite a hazardous combination of gases. And the word intrinsic means by design. That means it's being used the way it was intended to use. It's not broken, it's not defective, it was manufactured correctly, so it must be used as designed. And the use part of it is also part of the intrinsic safety. You can't deviate from the way it's intended to be used and expect it to maintain its intrinsic safety rating. So the person operating the equipment is part of the intrinsic safety of the operation of the equipment. So what's necessary for an explosion or a fire or the combustion of gases or fuels? Basically, you need fuel, oxygen, and a source of ignition. Yesterday, I gave the Combustion 101 seminar, and we talked about that from a different aspect, but we're still talking about the same process, kind of the combustion triangle, if you will, fuel, oxygen, and a source of ignition. So there's that combustion triangle. The quantities, the amounts of oxygen and fuel have to be correct or within certain ranges, and the amount of energy present in ignition must be within a certain range for the mixture in order for combustion to take place. So it's a right place, right time, right amount kind of situation. An intrinsically safe product assumes that there's a dangerous amounts of fuel and oxygen. It'll assume that this part of the triangle is in the danger zone, that you're in an area where you've mixed. And even though it's not exposed to it all the time, it assumes that it's going to be exposed to something that's in a dangerous combination of fuel and oxygen. And therefore, it will limit the ignition energy, the amount of thermal or electrical energy that the device, the product itself produces, so it can never ignite a potentially hazardous atmosphere. So the product controls the ignition side of this because it can't control the real world, the fuel and oxygen side of it. So that's how an intrinsically safe product works. Section 7.1.1.2 talks about a combustible gas detector that has an adjustable tick rate. They're looking for one that has an adjustable tick rate, and from that I divine that it's looking for something that has an adjustable dial, like the Leakator 10 here does on the left, or a thumb wheel or a keypad, like you see on the Sensit HXG2D, or a thumb wheel in the Sensit TKX, or on the Backrack Leakator Junior, which has an adjustable range, a high-low range. So it's looking for a way to allow you to adjust the tick rate so you can home in on the source of the concentration. And basically, the requirement is they're looking for a relative indication, not an absolute indication of concentration. However, if you went for the gold here and got something with a digital display like the Sensit HXG2D, that's fine, as long as it has some way of determining the adjustable or the volume concentration in a relative sense. So you're looking for more here and less there. That's what you're trying to find out when you're using a leak detector in this kind of mode. I get a question here, where does the standard say adjustable? It says a variable tick rate. That may be an editorial issue with my slides, so I will check that again, Matt, and make sure that I got that right. I'm going to make note of it right now. The standard says what it says, and I apologize if I misinterpret it here. Section 7.1.1.3 talks about an LEL alarm. We're looking for the device to be capable of providing a digital display of the percentage of the lower explosive limit and or an alarm. So you need not have a digital device, a digital display, but you can have a digital display. That and or allows you to have either one or the other. But they're looking for an alarm when it detects combustible gas concentrations that exceed 10% of the lower explosive limit. And we'll explain that in just a moment. Just to give you information, the lower explosive limit is specific to the gas to the type of fuel gas that you have. Propane or methane are the two most typical types. So you can't really say a percentage of gas because the lower explosive limit for propane is 2150 ppm. 10% of the lower explosive limit for propane is 2150 ppm, and 10% of the lower explosive limit for methane is 5000 ppm. So that's why it's stated in lower explosive limit. It's kind of a relative scale to the fuel gas of interest. You couldn't say a specific ppm number because it is different for the two different major types of fuels out there and a significantly different amount of concentration of gas. So the explosive limit depends upon the fuel, and the 10% low LEL is a different concentration, but the meters that are set up to show the digital display, you need to tell them whether you're in the methane or the propane mode. So here's some characteristics of combustible gases. And this little chart here gives you an idea when you move from an area where you have too lean or not enough fuel for the amount of oxygen present to support combustion in with any kind of source of ignition. There's just not the right mixture there. When you come up to the first level, it's the lower explosive limit. That's the point at which you have just enough fuel and air mixture in order for it to create an explosion. And anywhere above that point, it will support combustion with the source of ignition. Moving up to the upper explosive limit, when you get to the upper explosive limit, that's the point where it's too fuel rich. There's too much gas concentration in the air for it to support combustion. So above the upper explosive limit, it's too fuel rich to burn. Red zone here within, it's can explode or burn if an ignition source with enough energy is introduced. And here we go back to the enough energy statement. Enough energy comes from the way the device is designed. Designed and used to make it intrinsically safe. Below the green area here, below the lower explosive or lower flammable limit, it's too fuel lean. There's not enough fuel to burn. Something to pay attention here, we've got green, yellow, and red lights stacked up a little differently than you would see at a traffic intersection. Green at the bottom for too lean for combustion, but red moves into the red zone where it will support combustion, will support explosion. It's yellow up here above the upper explosive limit, because as soon as this concentration drops back down and there's enough air or oxygen present, it will move into the combustion and support combustion zone. So this is not a safe area by any means because it can rapidly change into a combustible zone. So LFL and LEL basically mean the same thing: lower explosive limit, lower flammability limit, lower flammable limit, and then the same thing with the UEL and UFL. When it comes to measuring gas concentrations, we're showing here C3H8, which is propane. The typical units of measure are parts per million, or percent LEL or percent UEL. And usually it's percent LEL because we want to stay on that safe side in that green zone and stay well below the area getting into the red zone. However, concentration of gas is measured in percent by volume. So 10,000 parts per million is 1% by volume. The parts per million is percent gas, but the LEL depends upon the type of gas. So the LEL concentration will be different for different types of fuel gas. Again, the two major ones, methane and propane, with 10% LEL being 5,000 ppm methane and 10% LEL being 2150 ppm propane. Section 7.1.1.4 talks about calibration of the combustible gas detector, and the statement's been rewritten since the last revision, and they're looking for it to be calibrated or checked in accordance with the manufacturer's recommendation with any available documentation traceable to the individual device. So basically, they want calibration records of whatever sort kept conforming with the manufacturer's recommendation. Now, there's still a little problem here because the Leakator 10 manual does say the Leakator 10 does not require calibration at regular intervals. So there's a little bit of meshing that will have to be done here between the manufacturers and the standard. I expect a few more explanations or corrections as we go forward with this. 7.1.1.5 talks about zeroing of the combustible gas detectors. and this that's an incorrect number there, but we're 7.2.2.6, that's not correct anymore. But we're looking for a combustible gas detector to have the ability to zero in ambient conditions. And that means to adjust out for background levels so that you can see as the concentration rises and you're getting to the source or the heart of where the leak is. And either the thumb wheel or button can be used to zero out the background levels. This adjusts for the threshold, or the same can be done on a digital device to adjust for the digital threshold to zero it. One kind of divergent topic I wanted to talk about here is odorants in natural gas. Methane, the way it comes in nature, is not detectable by smell. Pure methane does not have a natural smell associated with it. So odorants are added in the processing process of basically manufacturing the gas, with methyl mercaptan being the most commonly added odorant. It produces a rotten egg smell, or kind of a sulfur gas, a sewer gas smell. And the odorant is detectable by most people at parts per billion level, very, very low level, has a really strong reaction. So 1 to 3 parts per billion is usually enough to allow someone to detect that. So the addition of a little bit of odorant to the gas stream allows it to be detected by most noses. Now, odorant can still be detected at 0.1 parts per billion. The odorant can be sticky enough or present in the air to give you the concept or the idea that there still is a gas leak present, even though the gas is dissipated. And noses are not accurate. They're not calibratable. They're not all the same. They can be affected by an individual's health. So this is sort of the fallback safety position, is to use your nose to smell, but it is not a measurement. It is not to be relied upon as a gas leak detector. If you do smell something, you should probably and you're professional, then you should probably bring out your tool, your concentration detector, your leak detector, and use it to finally narrow down on the leak. You can also, individuals can suffer from olfactory fatigue. Basically, your nose gets tired of smelling the same thing and it stops smelling the difference. So if there's enough odorant around, you cannot detect it. You might not be able to detect that there's actually a gas leak present. So what do we end up looking for in a combustible gas detector? Intrinsic safety, and that would be noted or marked on the instrument with a marking such as UL 913, which is an intrinsic safety standard, and indicate Class 1, Division 1, in groups C and D for sure, must have that, or it could be A and B. And these talk about the different atmospheres that are present, but the C and D cover the market that we're looking at. You'd see a mark or written description such as this here, in the sense this is lifted directly from the Sensit TKX instruction manual, where they say it's approved for Underwriters Laboratory 913, Class 1, Div 1, Group C and D. So that complies with the intrinsic safety intent of the standard. But it also says, when used with Duracell MN1400K or equivalent alkaline batteries, here's where used as intended is part of your obligation as the end user to maintain the intrinsic safety. You can't use a different battery and still have it comply with that. They've tested to be sure. They know there's a repeatability to the manufacturing construction of those Duracell batteries, such that that's the way they want it to be used. And that's the part where you have to make sure you're using it, and using it correctly in order to achieve and maintain the intrinsic safety. You're also looking for an adjustable or variable tick rate. Again, going back to that note, which I'll check again. And then providing a display or an alarm above 10% LEL. A calibration documentation, quote unquote documentation, some traceability, and the ability to zero the device. So these are the main things you're looking for. I've been asked by a couple people, can you tell us exactly which instruments meet the standard? Well, since the standard is not issued, I can only give you advice and point you in a direction. When the standard does become official, I will create a list of compliant instruments but that will only be after the standard's released, because I'd hate to release something, have it floating out there, and have the standard change underneath it. So once the standard's out, I'll create a list of compliant instruments for all these aspects. There's also a little bit of confusion over the 10 ppm threshold. When people were originally reading the standard, going back to earlier this year, they had noted the 10 LEL, and then in some areas, I think it was actually New York State, they were looking at a threshold for the detectability of the gas at, I believe it was 20 parts per million. Well, most detectors are at 50 and a few are at 20. Then people read the 10% LEL and thought that had now dropped to 10 ppm threshold. You'll notice throughout the standard there is no lower level detectability except this ability to detect the alarm level at above 10%. So there's no threshold, there's no 10 ppm threshold. That's a misinterpretation of what the standard's trying to convey here. Now let's move to the carbon monoxide measuring equipment. 7.2.2.1 talks about a range of 0 to 2,000 parts per million, and looking for equipment to measure and display digital carbon monoxide levels from 0 to 2,000 parts per million. So that's a pretty easy achievement for most of the meters on the market. It adds in the additional criteria of CO-AirFree, 7.1.1.2. And what that is, it's looking for the capability to calculate and display digital numbers for CO-AirFree calculation, or have an oxygen and CO level displayed so you can manually calculate CO-AirFree. Now, I actually have a whole 1-hour webinar tomorrow just on CO-AirFree to really explain and break this down and give you some detail on it. But I will go into it and touch on it a little bit here. What is CO-AirFree and why is it part of the standard? So normal air has 20.9% oxygen present in it, and the normal CO-AirFree calculation is usually up to about 99.99 or close to 10,000 ppm is what the calculation usually displays in most analyzers. CO-AirFree is also called CO undiluted, and basically that's a really good name for it, CO undiluted. It removes the impact of the diluting air. We're going to go over what that means. So this comes from our combustion webinar and also the CO-AirFree webinar, but we're going to just do a real quick illustration of CO-AirFree. We have on the left axis the flue gas components in increasing concentration, and then an increasing amount of air going into combustion. Because air is kind of like, a lot of times is the gas pedal for combustion. You can vary how much air is going in to impact the rate of combustion. Stoichiometric line is the line of perfect chemical balance. That's where everything is coming in at just the right concentrations to achieve optimum combustion. Again, we're talking about combustion, not explosion here. But still the same kind of parameters or thought processes are involved. On the left side of stoichiometric is incomplete combustion. On the right side is complete combustion, where you have more than enough air, and here you have not enough air to complete the combustion process. So here's the oxygen line. If you had the ability to dial the air concentration in going into combustion and be increasing it from a low value to a higher value, you would eventually see residual oxygen in the flue gas. So again, these numbers up here, what we're seeing, would be the numbers displayed in your flue gas analyzer. So as you dialed in more air, you'd see more oxygen being produced because you're introducing more air into the system. At this point, you had air still coming into the system, but there wasn't enough air to go around. So you're actually using up all the air and you had no residual or excess air. So this is the excess air line. The CO line, CO production drops as you increase the amount of available air to mix with the fuel so that the carbon in the fuel can join with the oxygen, and you want to create CO2. That's the true objective of combustion, is to create maximum CO2. That's maximum energy efficiency. But if you don't have enough oxygen around, you only get it to CO, not all the way to CO2. But those levels will drop as you provide more and more oxygen available in the combustion system. And in the real world, you do get a little bit of CO coming past the line of perfect chemical balance, the stoichiometric line. If we could somehow remove the impact of the diluting oxygen and look right straight back to the intersection where CO comes over the stoichiometric line, where it comes to the point where there's 0 oxygen present, that is the CO-AirFree number. And the CO-AirFree number then does not change as you increase the oxygen level. So it provides more of a system fingerprint as to how it's running for the absolute amount of CO there. I'll go back a couple steps. One of the main reasons that the CO is dropping here is part of it is due to dilution. The concentration gets much less because you're adding excess air to it, you're diluting it. It also drops because there's more air available to reduce the amount produced, but there still could be an amount produced. That amount produced, if you could look back and see where it is, where it crosses the threshold, the stoichiometric line, that's what CO-AirFree is. It's the ability to use a microscope and look back, no matter what set point you are here for oxygen reading, you can look back and see your CO-AirFree have one number going back here. The actual calculation for CO-AirFree is you take the raw CO number off the sensor and you multiply by 20.9 and divide by the quantity of 20.9 minus the actual raw oxygen sensor number, the amount of oxygen coming off the sensor. Now, most analyzers stop the calculation over 16 to 18%, or in converse, actually don't start the calculation until they're below 16 to 18%, because those numbers of 16 to 18% are close to ambient conditions of 20.9. So your analyzer is not broken if you have really high oxygen levels. It just isn't going to calculate a CO-AirFree reading. This got in a little bit out of order here, but so we're looking for in a CO measurement tool is looking for the range of 2000, 0 to 2000 on the digital display. So it must have a display. It must have a CO and oxygen sensor. Has a resolution of 1 part per million and an accuracy of plus or minus 5% of reading or plus or minus 10 ppm, whichever is greater. So that basically that puts you in the ballpark of just about every commercial available combustion analyzer at this point that has an analyzer that has a CO sensor. It also does ask that you have it equipped internally or externally with a nitric oxide filter. And we'll go over in a minute. We'll give you a quick snapshot of that, talk a little bit more about that tomorrow, and we did yesterday in the combustion seminar. And also be calibrated in accordance with the manufacturer's recommendations, and then have some traceability of the calibration. So a couple things here at TruTech we have to offer is we do sell a NOx filter that you can equip if you don't have one present in your equipment. It's $39.95, and that includes shipping. We also do offer calibration service, so and calibration documentation, so that you can make sure that you are complying with this standard. There are other locations to get those same equipment and services, but just want to make sure you're aware of the ones at TruTech. So here are a couple products side by side. We're not doing any brand bashing here, but just to illustrate what you can see if you're running a combustion test with and without a NOx filter. So we have 27 parts per million being displayed on the instrument at the right, and only 6 parts per million CO on the left. Most people would think because it has a lower number, something's wrong with the instrument on the left. In fact, there's something right with the instrument on the left. We're also seeing this instrument on the left has the ability to measure the nitric oxide value, so it's reading about 38 parts per million, 38 to 40. The way NOx affects the CO sensor, it's also an acid gas, it affects it at a ratio of about 50%. So 50% of the 40 ppm or so is about 20, and that leads to this being off by about 20 parts per million. So the combination of nitric oxide plus the CO is being shown here as only CO on this meter. Now, if you applied a NOx filter to it, you would see that drop down to the 6 or 7 range and give you the correct reading. And because CO is the basic input to the CO-AirFree calculation, you must get that correct. If you don't get that correct, you're going to have an inflated CO-AirFree number and then trouble with that. We're also see the description in the standard 7.1.3.1, where it discusses personal monitors. where the auditors performing CO inspections shall have a dedicated ambient CO monitor while working in the work environment. And then it describes the work environment, preceding entry into the audit, looking for exposure in the environment preceding entry, as well as inside the building being audited and the ambient air. So it's important to be sure you have a dedicated personal CO monitor. To go a little bit further, of course, they say that it should be operated in accordance with the manufacturer's instructions, and then some details. You should conduct the procedures to measure carbon monoxide levels and CO levels and take action as required. And only after the CO and combustible gas levels are found to be below the evacuation levels shall further work be undertaken. Now we'll go into what those levels are in just a moment. We do talk about zeroing of the product, making sure that you have a good reference point for it. The combustible gas detector, personal monitors, and CO instruments shall be turned on outside, away from any combustion outlets, set to 0, or other prepared for use in accordance with the manufacturer's instructions, because they may not always require being set to 0, so you do need to follow the type of instrumentation that you have. For combustible fuel gases, there's a process here, sampling at least one location per floor before entering the home, the indoor ambient air. And then if any concentrations exceed that 10% LEL, so it either would be by the alarm or by the digital display, then you need to advise the homeowner. For the carbon monoxide factor, you should have the carbon monoxide monitor operating at all times when you're in that work environment as described previously, and comply with the CO level exposure action levels, which are next. And then sort of the bottom line is here, not proceed with CO work, when the CO concentrations in the work environment exceed 70 parts per million ambient level. So when you enter the building, you measure the CO in the occupied space, including utility rooms, and continue to monitor when you're in the work environment. That's why it's so important to have a constant duty, always on CO monitor. Now this gets a little bit dense here. I tried to highlight the salient points. I'll try to work on this slide a little bit better for next time. But basically, 70 parts per million or greater, you must terminate the inspection and notify the homeowners, leave the building, and notify emergency services. That's if you have more than 70 parts per million in the ambient level. The next section talks about the range of 36 to 69. You should advise the homeowner and recommended that CO possible sources, be turned off immediately. And if that means it's a permanently installed appliance like a furnace or water heater, you must contact the qualified professional to do that shut off. Then in the range of 9 to 35, you give advice that CO has been detected, recommend that CO be checked and windows and doors be opened. So you're giving recommendation that things are not looking correct when it's above 9 parts per million. So it's 9 to 35, 36 to 69, and then 70 and above. Let's run poll question number 3, which will be our last poll, I believe, for today. So based on what you heard, are you going to be finding yourself in the market for changing your test gear? And I got a question here while you're answering. The per survey from Howard, will we be able to replay the webinars after the broadcast? Yes, there'll be a video available on our YouTube channel. And if you recently received this analyst certification, do you need CEUs? Yes, you do. There's a whole description of the CEU process on the BPI website. And yes, but please contact me afterwards about submitting your certificate number for Tuesdays and Wednesdays webinar, if you didn't do that already. Okay, so the answers here, we'll close the poll, share the results. People are saying 41% yes, 41% no, and 18% not quite sure. And I think it's easy not to be sure because it's a new and it's a changing thing. It's dynamic, so we'll all try to figure this out together. So are there any questions? Howard, if you want to send me an email or send Jamie an email, jamie@truetechtools.com, and mention the 2 sessions with your full name and your candidate number for BPI, and she'll make sure she enters that in the portal. Okay. We do have future webinars coming up, and you can find those on our website. The comment deadline, Michael, is December 15th, Monday, December 15th. So you have just a little bit over a month to review the standard, mark it up, and feedback using the BPI mechanism that we showed before. If you're wondering about other resources we have at TrueTech Tools, we've created a resource link on our homepage. It's near the top of the category section. These are mainly free resources, free troubleshooting guides, combustion downloads and guides. We have videos explaining how to use processes and products, and how, more education, more learning, links to our webinars, and books and guides that are also for sale. So it's truetechtools.com/resources is where you'll find that information. As I mentioned before, best way to keep up to date, we stay active on different technical committees. We're asked for our advice by manufacturers and end users, and we learn from end users and manufacturers and the technical committees and the trades. So we're sort of at the nexus of this instrumentation thing for HVAC and for building performance, and we like to share what we've learned and also learn more ourselves. So here's all the different ways you can stay up to date with us. And again, the best way is probably through signing up for the newsletter. These short links, these bit.ly links, you have to be careful with them. bit.ly/, and then make sure you hit the upper and lowercase and hyphens exactly as they're shown on the screen here. Okay, if you haven't heard any other questions, I want to thank you for your attendance and your participation today.